Do you want to stay around to just...
Yeah, he's coming. That's him.
Okay.
The pointer flips the presentation also.
For distinguished speaker series, I would like to call first to the podium Sarah. Is Sarah here?
Ladies and gentlemen, welcome to tonight's lecture from the Distinguished Speaker Series. Technology, said the physicist Freeman Dyson, is a good servant but a bad master. At a time when technology is reshaping society at an ever faster rate, we understand more than ever the importance of Dyson's statement. According to the Accreditation Board of Engineering and Technology, ABET, in becoming engineers, we are making a commitment to have broad education necessary to understand the impact of engineering solutions in a global and societal context. As part of Khalifa University and the global community, we feel that it's our responsibility to make the effort and contribute to paving the way for a brighter and sustainable future. That was our reason for establishing the Green Crescent Khalifa University Environmental Club. Through Green Crescent, we try to engage different layers of the society based on their interests, conveying what is going around the world in terms of environment issues and green solutions. Also, we reach out to the children, intending to develop social responsibility towards the environment. Finally, I'd like to say that we are sailing one ship, and we must ensure that we are going the right way towards sound policy, prosperity, and peace. Please welcome our President, Professor Tod Laursen.
Thank you, Sarah. Good evening, everyone. We're very proud of Sarah and her colleagues in the student groups and what they've done with the Green Crescent Club. I think those of you who've been around Khalifa will realize that we're blessed with a number of very active student groups, and to have had this group of students take on this particularly important issue is really great for us as a university, and we're very proud of these students. I'd like to add to Sarah's welcome to the Distinguished Speakers Series. Tonight, as the title will attest, our speakers addressing a question of great importance and perhaps of great generality too. Will innovation save the world? We hope that Khalifa's commitment to advancing research in science and technology can make a contribution, obviously, to improving the world, exactly as that title suggests. But we also know, if we look at history, Freeman Dyson's writings were referred to earlier, I think is a good case study in that. We're aware that research and innovation also have the potential to have the opposite effect if they're not intelligently applied and applied in context and with understanding of the society in which we live. And it's really our hope to avert these outcomes and to make sure that the work that we do here as an academic institution has a positive impact, that we seek to have a broad understanding, and for our students to have a broad understanding of the relationship between science, technology, and society. So really the idea behind this series is to bring leading experts to bring different perspectives to bear on the best paths forward. And this is really what the Distinguished Speakers Series in Technology, Science, and Society is all about. In particular, for this evening's event, and I think those of you who've attended events in the past will realize that this is a new step for us. We're particularly indebted to the Emirates Center for Strategic Studies and Research for their partnership in this creative effort. This is really the first event that we've done together with ECSSR, And we're greatly indebted to ECSSR for their partnership and indeed for providing this fantastic venue in which we're meeting this evening. We look forward to a continued relationship with them and thank them very much for the role that they have played in helping us bring these issues to the broader community beyond the university's walls. So clearly, bringing this back to tonight's lecture, the issue of climate change is critical for the future of our planet, and Professor Schellnhuber, as many of you know, is a leading voice on that issue in the scientific and policy community. It turns out in our discussion earlier, he and I share something of a shared theoretical interest, I guess, in nonlinear dynamics, chaos, which I don't think you're going to precisely talk about this evening. But I think it's at least one example of someone who has really had great impact within the scientific world, but has been able to really think beyond that and to think about how to have a broader impact together with fellow scientists and policy experts about the issues confronting us in society. He's warning us of perils confronting our planet and has championed, as many of you know, the responsibility of scientists and engineers to contribute to addressing the threat, and we're very honored that you've been able to join us for this visit. So at this point, I'm going to turn things over to my colleague, Professor Micheline Yichet, to introduce the speaker. Micheline is a distinguished scholar and author of many books in political theory and international studies. And perhaps most importantly for this evening, she directs this speaker series and has really been a driving force behind its evolution and development. And I'm personally indebted to her for that. And she will both introduce the speaker and then facilitate the discussion afterwards.
Thank you.
Salam alaikum. One way technological innovations can become a real nuisance in a lecture is when people's mobile phone ring. And so I'm going to just ask you if you could just turn your ring. Can you turn your cell phone? We want to save the event, if not to save the planet. So to make sure that it's not lost in translation, this is for you, Nadine. Al-Raja Ikaf Il-Hataf Al-Mutaharik. Shukran. And now with our German speaker in mind, I would like to invoke the famous 19th century German poet, writer, artist, biologist, theoretical physicist, and polymath, Johann Wolfgang Goethe, who wrote a wonderful sentence that I would like to quote. It's easier to perceive error than to find truth. The former lies on the surface and is easily seen, while the latter lies in the depth where few are willing to search it. When I first heard Professor Schellnhuber in Berlin, I think it was a year and a half ago, I knew immediately that he was one of those who search not only for errors, but for the truth and solutions beneath the surface. So in a sense, Professor Schellnhuber is following in the footsteps of great people, 14th century Arab scientists, Ibn Khaldun, who bridged the fields of physics, engineering, economics, and politics. So that interdisciplinary approach is becoming too rare in our time as field of academic study becomes ever more specialized, sometimes at the expense of the big picture. And so Professor Schellnhuber exemplified the applications of expertise in particular field with the search to address problems that are global in scope. His insights and achievements have been already recognized not only in his country but worldwide thanks to his prolific scholarship. He has authored, edited more than 250 articles, has written about 50 books or so. He's writing something that is very interesting right now that he was talking to me about on the history of climate change. He has written in the field of condensed matter physics, complex system dynamics, climate change. He founded and led the Potsdam Institute of Climate Change in Berlin, and only today told us that in Potsdam he inherited the office of Albert Einstein. Well, we are envious. He's currently chair of the Global Advisory Council on Global Change, as well as governing board chair of the Climate, Knowledge and Innovation Community of the European Institute of Innovation and Technology. He served as chief government advisor on climate and related issues, and is a principal advisor to the European Commission. He's a recipient of many awards, prestigious awards. They include the Commander of the Most Excellent Order of the British Empire. So those are just some of his achievements. There are so many more, and time won't allow me to give the full, complete list, and forgive me for that. For now, ladies and gentlemen, please join me in welcoming our guests. Welcome Sie, bitte schön, Herr Professor Schellnhuber. Welcome.
So, thank you very much. I have to thank everybody who has set up this evening. It's a real privilege to be here in one of the most exciting places in the world. I've been to Abu Dhabi, I think that's how it is pronounced, 20 years ago, and I do not recognize it anymore. It's amazing. I'm also very glad that I'm part of the speaker series for the Khalifa University, which is a very interesting experiment you're doing here. I had a chance to talk to the president and also to the executive vice president about your vision and ambitions. It's a very interesting enterprise. On my title here, this is tongue-in-cheek, of course. Will innovation save the world? But it's not entirely tongue-in-cheek. It also means, according to my own insights over the last 20, 30 years, without innovation, we will not be able to provide 9 billion people on this planet in the year 2050 with a life and dignity. Yeah? It will not be possible. The question is, of course, will it be innovation as usual? We talk about business as usual, and we have innovation all the time. Do we have to speed up innovation? Are there completely different approaches? Talking about engineering, we can also talk about the so-called geo-engineering. You know that we will actively manipulate sunlight in order to compensate global warming. I've just written a paper about it that appeared in the US National Academy Journal, PNAS. Or do we have to take on board, as natural scientists, as engineering, the ethics issue, and I'll talk about all that, actually. Micheline, is it possible to dim the light a little bit for the slides? You don't have to do that, but maybe there is somebody, a helping hand in order to do this. Okay, anyway, so let's get started. Now this is a very interesting picture. You know, I started when I was the personal scientific advisor to the German Chancellor, Angela Merkel, who is a theoretical physicist by training too. Then in 2007, I started a series of Nobel Laureates Symposia dealing with the issue of global sustainability. And here you see we had this meeting in Sweden, in Stockholm actually, together with the Swedish Academy of Sciences and the people who give away the Nobel Prizes. We had this meeting in May, so we had the Swedish King and Crown Princess Victoria and so on. But this is a meeting and assembly, if you like, of probably I would call it an intellectual singularity on this planet. Because the people you see there are 25 Nobel laureates, but also other interesting people like Lord Stern, who is famous for the Stern Review on climate change. You have Amartya Sen here, the famous Nobel laureate in economics from Harvard University. And here in the first row, Nadine Gordimer, the Nobel laureate in literature from South Africa. Murray Gell-Mann, who invented quark theory, who is a friend of mine at the Santa Fe. what is my former teacher at Santa Barbara, Walter Cohn, a Nobel laureate in chemistry, and so on. Paul Crutzen, who did the theory for the ozone hole in the stratosphere, and so on, and so on. Peter Doherty, Nobel laureate in medicine. So that is a meeting we had, and it was all on global sustainability. Yeah? So it was in Stockholm in May this year, and some people may know that this lady, it's Gro Harlem Brundtland. The Brundtland Commission started this entire topic of environment and development, and the word sustainability, sustainable development, was coined by that commissioner. So this was a gathering of outstanding minds, and it was all about the question, can we achieve a transformation towards sustainability on that planet? And why this is necessary, I will talk you through that, and also about the potential solution. So, this is a sort of word I use, the Pyrocene. It means, Paul Crutzen has talked about the Anthropocene, that is the geological age of humanity, of anthropos. The Pyrocene is the first stage of the Anthropocene in a sense. It's the age where we burn all our fossil fuels. So pyro, you know the Greek word. And it is a necessary stage in the human development, clearly, but it's not the last stage in our evolution, I can guarantee you. So I'll just tell you a little bit what I mean with that. So first of all, I did a paper in Nature together with my colleague Johan Rockström. He was the lead author. It's called Planetary Boundaries, Safe Operating Space for Humanity. And it was about this idea, or maybe I should tell you about that in the beginning. You know, the paradigm which was created in the 1960s, 1970s, carried on in the 1980s was, we have no planetary boundaries in a sense. Resources cannot be depleted. It's an open space, and in order to develop our society, we just have to grow, expand. Now, with the financial crisis, for example, we have learned there is no open space and there is no exponential growth forever. So what do you have to do if you want to further develop yourself? If you have boundary conditions which make an expansion forever impossible, you have to transform yourself. Transformation means you change your shape, so to speak. Yeah? Now, these are the planetary boundaries we found. So this is a space of 12 dimensions and so on. And we have found out that on the climate issue, but even more so on biodiversity and on the nitrogen cycle, that is the fertilizers you use in agriculture, we have gone beyond the planetary boundaries, that is this green circle here already, but we are heading for going beyond that threshold in many other dimensions. Give you just one example, that's ocean acidification. You know, when people talk about climate change, we of course talk about global warming. Yeah? So we are interfering with the climate system, and I will tell you a little bit about our expectations in that respect. I think very relevant for the Gulf region here. But there is a side effect of CO2 emissions. If you emit through burning of fossil fuels, CO2 and other gases, that is, most of the CO2 from the atmosphere goes into the oceans, which is good in a sense because it's taken away. But if you add to a bottle of water, this is still water here, right? It's not sparkling water. But if you add CO2, you turn it into sparkling water. That's this one here, which is nice for you to drink. But it means it has a major impact on all the ecosystems in the oceans. And actually we have calculated with ocean acidification, if we go on business as usual, the oceans will get so acidic that all the coral reefs will be dissolved. And that is a major problem, of course, for the stability of coastlines and so on. So, you know, below the radar screen of global warming, this ocean acidification is a major problem. And you do not need complicated theories. It's very elementary chemistry you have to do. So that is one of the problems we have spotted, if you like, and where we hit one of the planetary boundaries. So it all comes from this development here. And this is a chart of the world population development over the last 12,000 years. Here you have a linear scale. So that is today. Actually, we are now 10 years later, and we have 7 billion people on this planet. And you go back to minus 10,000 years before Christ. Here, this is a linear scale, but this is a logarithmic scale. So engineers love logarithmic scales, of course. But what you see here, if it would be just an exponential growth, it would be a straight line. What you see here is super exponential, this growth. So you had, you see, it even works. That's good. I was told it doesn't work, but you know, technology even works at Khalifa University or here at the Institute. That's very reassuring. So this was 1 million people just 12,000 years ago. Now it's 7 billion, so it's a super exponential growth. And that always comes with a cost. One of the costs is global warming. Now again, you know, we have this debate in the United States, for example. If you have a cold winter, people think there is no global warming anymore. But the real data in the real world are always, you know, noisy. All the lines are sort of going up and down. This is the global mean temperature development. You know, the annual mean. That's the black curve since 1880. You know, it goes up and down and so on. Here is a recovery from the volcanic eruptions we had before in the Little Ice Age. And here you had a sort of masking of global warming through sulfur dioxide, so air pollution, the ordinary air pollution. And when a system takes off, like here, greenhouse gases dominate. So that's definitely a problem. Now, people just stare at a certain part of that curve and say, you know, here, for example, this was the end of global warming. But of course it wasn't. Everybody who is doing experiments in your lab sees, well, these curves go up and down, but what matters is the trend in the end. And for climate science, you always have to take at least a 30 years trend. That's the only reliable trend you have. Now, there was a huge debate called ClimateGate just before the Copenhagen conference, you know. I was a member of the German delegation where it was an unheard of meeting. 120 heads of state or chiefs of government went there, so including Obama and Wen Jiabao and many others. But it was a complete failure, the conference. Just a month before the conference started, some people had stolen emails from the University of East Anglia, where I also was a professor once. So my emails were included, actually. They were put on a Russian server and put into the internet. And people said, this is the proof that climate scientists are manipulating data. Now, there have been many independent commissions now looking into that matter and clearly have sort of told everybody that there was never manipulation of data. But because of that, a group called the Berkeley Earth Surface Temperature did a project. These were climate skeptics, and they said, well, we are theoretical physicists, we know better than the climatologists. We will do with the best statistical methods the reanalysis of the data, and we will find out that the planet has not warmed at all, actually. Now I'll show you the result. Actually, it was published in the Wall Street Journal, not in a scientific paper. That will happen also. It was really an editorial and a publication in the Wall Street Journal, and I show you the data. Now these are, you know, the leading climate centers in the world. So the Hadley Center in the UK, NOAA, based in Colorado, NASA, Columbia University. So the data on global warming, and this is what the Berkeley Earth Surface Temperature Project found out. And you see it matches completely the previous analysis. So that was the end, if you like, of any doubts in whether global warming is a real thing. But it didn't help at all, because at the time of the Copenhagen conference, there was a lot of mistrust and sort of discrediting of the credibility of the scientific system and the scientific community. So it really took its toll, and in the end, the climate talks more or less collapsed completely. Now, let me talk about how the use of energy has changed the world over the last 300 years or so on. It is an interesting curve. It's just about the primary energy in exajoules, so that's a huge number actually, used since 1850. That's biomass, it was just cutting down trees and things like that. And you still see it's very important. It has grown, this part. But we have added other components of the energy system. So around 1800 and so on, coal was introduced in England. And that started the Industrial Revolution. It's a very interesting story, actually. And you see, it was directly related to the steam engine. The interesting thing is that the steam engine was not used because there was coal and you could have a locomotion or things like that. It was the other way around. Because in England, all the forests were cut down, people had no firewood anymore. In London, for example. So people needed coal to burn in order to heat their houses. Although this is a very unpleasant thing. If you have an open coal fire, you will choke and everything, a very unpleasant thing. In order to get the coal out of the mines, you had to pump the water that goes into the mines immediately. And the horses couldn't do it anymore, so the steam engine was invented to get the coal out of the mines.